Greetings, Earth enthusiasts. If you ever wondered about the incredible perspectives our planet has to offer from high above, you're in the right place. I am Dr. Clive Coetzee, and I'm thrilled to be your guide on this captivating journey into the world of remote sensing. Welcome. And please remember to like, subscribe to, and share this video. Thank you.
In the previous video tutorial, tutorial 55, we made sure that we have our region of interest as an asset within our project, and we also then created a 1,000 random points layer within our assets, and we said that we can use them for very different purposes or different reasons, particularly to generate the underlying data, in this case monthly maximum temperature data for our region of interest, and then also for the 1,000 random point locations. Remember, the 1,000 random points are actual locations within our region of interest, and so what we want to do is not just generate a time series for our region of interest as a whole, but we also want to generate maximum temperatures or the time series for each of these 1,000 points. Now, the 1,000 points depends on you. You want to do 2,000, do 2,000, you want to do 200, do 200. That is up to you. But in general, remember, more is better. But also just bear in mind that you may run into size issues and limits, timeouts with Earth Engine. So it's a fine line between having too many and too little random points. But anyway, so we have two files for our layers, one for my region of interest, which is a boundary layer, and one for my 1,000 points. So what we want to do now is, as I said, generate a time series for my region of interest, and then also generate a time series for each of my, as I indicated here, for my 1,000 locations. Okay, so this is just for location 1, for example. Okay, so remember I've loaded my two layers. Well, I started with the layer, boundary layer for my region of interest. Okay, so now you have two options. You can either, as I said, generate your 1,000 points in QGIS and then bring that file into Earth Engine, or do everything in Earth Engine. That is totally up to you. Whichever method you prefer, use that. Okay. Remember, what we've done is we've generated the 1,000 points layer within Earth Engine. Okay, so remember, we just say random points, EE feature collection.random points, and then my region is my region of interest, this region. I've got 1,000 points, and then, as I said, these are just attributes that you can change if you want to delete it. So now you have, as I said, two options. We've generated this random points file now. There we sit. Sorry, not that one. This one here. There they are, the green ones. That's 1,000 points within our region of interest. Two things. We can export it as a CSV file. So that's one option. Now you can export it as a CSV file. Open it in your computer on your project folder and convert it into Excel, and then you can do whatever you want to do. For example, add columns, add attributes, data, save it back to CSV, and then bring it back into Earth Engine. So that's one option that you can do. The other option is you save it to your assets within Earth Engine itself. Okay, so that means you skip going out of Earth Engine and coming back into Earth Engine. You do everything in Earth Engine. So basically what I do is I generate a asset, and the asset I'm calling random points tutorial, and its asset ID is also random points tutorial. Now, as I said in the previous video tutorial, you can have different names, you can change the names, that's up to you. And I said, when you run this, both these export options will be in your task manager for you to activate and to run. And you simply just click run. And once it's done, as I said, there it sits. It will now come into your assets. Okay. Now, here is where you can't simply just use that asset now, this 1000 layer asset as is, because in that asset, if we go to the asset details itself, so if I go to the asset, I click on it, this 1000 random points layer, you'll see now, let's just give it a couple of seconds quickly. You'll see that everything here is fine. You see there's the 1000, red location, everything is fine, except if we go to the features, you'll see we need an additional column here. And we need an ID column, so to speak, for us to generate the time series for each of those 1000 points. So I need a column here. I need an extra column here. I cannot use any of these columns. It's not going to work. So I need an extra column here. So I need to generate an additional column, which I can then use as my ID column for these individual points, individual 1000 points, which I can then reference to my code. Okay, that will become apparent now. Okay, so I can't. So for example, in the random points file that I've generated in QGIS, if I open this, you can see here random points. Okay, so if I go there, you'll see that in my column, I've got more than one column. You'll see there is I've included a random point, which is I use for my ID. Okay, so I need if I go to the random touch, this one here, if I go there, you'll see the column only have one column in the columns. It only has one column, which is the system index, which is basically the reference file. I cannot use that column. So I need an additional column. So I need to include a column into this asset or into this table, which is similar to this one here, that I can use to generate the time series data. So there's a problem here. So if I go to my asset, this one here that I've generated, that's 1000 points. I saved it to my asset, and I bring it into my code. I just basically, as I said, just left click here, okay, and there it sits. You'll see the random point stat, there it sits, random point stats. Okay, there it sits. But as I said, it only has one column. I need one more column. So I go in, I basically then create a feature collection of that asset. Okay, so I just say, and I give it a random name. This is just random points. Is Earth Engine feature collection, and then I just bring in the ID reference of that asset. Okay, so where do I get that? I go to this little cross here, I click on it, you see there's the ID. So I simply just copy that one, right? Highlight it, copy it, okay, and then I just paste it in there. Just paste it in there. Right click and paste. So now I'm creating a feature collection of that specific 1000 random points asset or table. Okay, so I'm giving it a variable name, which is now I'm going to create a random column. And that will be a column with random numbers in. It doesn't matter as long as there's no duplicate numbers. Whether it's 1 to 1000 or 0.01, totally random numbers, that's irrelevant as long as there's no duplicates. So I'm creating a random column and I'm calling it point. Okay, so the code is basically it's R, and I'm calling it FC is random points. This is this asset file here, this asset table, feature collection dot random column, and then if you don't want to give it a name, you just leave it empty and it will generate its automatic name. Otherwise, just in these little commas, put in the name of that column. Okay, so I'm generating that column now. Okay, so I'm going into this asset which don't have a column, and I'm saying let's create a random column with populated numbers. So there will be numbers, and I'll show you now. And then we export that asset now, this one here, this feature collection with this additional column. We're going to export that now to our assets as random point.fcc, random point.fcc. If I run it, you see there it sits. I run it, and after it's successfully completed, it will be located there. So now if I go there and I left click on it, you'll see it will have similar description, details, location, you see everything. But if I go to features, you'll see there's that column now. And it will give me random numbers here. Okay, it will give random numbers. As I said, it's totally irrelevant. Ideally, it should be from 1 to 1,000, but as long as each number here is a unique number, that's all I'm interested in. I'm not interested in anything else. It shouldn't be blank. That's the first thing. It must be numbers. It must be real, real numbers, and there mustn't be duplicates. So that's your criteria. So this is fine. Okay, you'll see there now. You can see clearly now I've brought in this point column within this asset or in this table, and now I have saved it in with my assets. There it sits, and then I bring it back into my code or my project as a feature collection. Same way I've done that. So I go to here. So remember, I've basically just imported it. There it sits now here. You can see there it sits. Okay, so if I open the details, you see the columns. It's got two properties now. And it's got a point float property. You see there, if I go into this one, it only had one column, this system index. You can see now it's got the system index plus a float. There is its unique identifier, ID. I right click and I say copy. Okay, let me just minimize these ones. And so that's important. Okay, so and then I just create a feature collection for that. Okay, so now I've got now my image collections and I have my feature collections or my feature collection with that for both my region of interest, which is a feature. And then I have my feature collection with my 1,000 random points with my extra column. Okay, so that's in the background. That's all the homework that you need to do before you can get going with the actual data itself. Okay, so that's quite important. Make sure that your assets are correctly specified, etc., before you start with the actual time series work. Okay, so now I'm happy. I've got my region of interest there, and I've got my boundary layer there, and I've got my 1,000 points, random points, points layer with that additional column. Okay, so now I'm confident that I'm okay. So let's have a look and see the two. There is my boundary layer, and there's my random points layer with that additional column, that unique ID column that I'm going to use. Okay, so first thing first, let's work with our region of interest as a whole, our boundary file. So what we want to do is we want to generate a time series for whatever variable we're going to use within the Terra climate data set. In this case, I'm going to use maximum temperatures. Okay, so remember you can change this to minimum temperatures, whatever. Remember your scaling factor. Always remember your scaling factor. So I'm going to, first of all, I'm going to start from, I'm going to create two variables, a start date and an end date. Okay, my start date is January 1960. Remember, this is monthly data. January 1960. My end date is December 2022. So that's basically the whole data set. So that is 757 months, plus minus. Remember, this starts in 1958, I think. So we may cut down a couple of numbers, months here. But anyway, 1960 to 2022. Okay, so first of all, what I want to do is I want to create, through this case, well, that's through this, I want to generate the number of months. Okay, so here I'm saying the number of months is end date, the difference between the start date, okay, and it's on a monthly basis. Oopsie. Okay, so here I'm calculating the number of months. You'll see now if I go, okay, we haven't printed the months, but if you say print in months, it will give you the number of months, which should be similar to this, except obviously that we've now not started from 1958, from 1960, so it will be less. Okay, so if it were yearly data, you just change it to years or to annual. I think it's year, not annual. Okay, so that will give you yearly data. Okay, so, and then we just round it off, and then obviously my data set is my data set as we use. That one here, filter date will be from the start date to the end date, so that won't be a specific date itself. It will be the start date and the end date, which is those two dates that we have created there, the two variable dates that we've created. Okay, and obviously I'm going to clip it, I scale it, etc., etc. You see, there's my system's time start and end start, end time end, time start, time end. Okay, so this is quite important. We're creating our months and we're creating our image collection. Okay, so now we know how many months there are and the images that we're gonna work. Now we need to match the images with the months. So that's what's happening in this piece of code, is that we're generating our months and we're advancing our months with by each month, meaning we start with a month, then the second month, then the third month, etc. And for each month we then select and this is what's happening here, is we add an image. Okay, so we start from the first month. Okay, so that's the list of the months. So we start with the first date. This is the start date here. Okay, remember that's the start date there, and then we advance by n, which is 1 in this case. As I said there, you can see there 1, and we're advancing by 1 per month. Okay, so meaning January to February to March to April. And all you'll do is you'll change this if it's yearly data or weekly data. You just change the month there. Okay, and then what we're going to do, what we're doing here is we're basically just adding. You'll see that the data scaled. Remember what is data scaled? Data scaled is my image collection. See, there's data scaled. It's my image collection because it's data sets. Remember, this is data sets, it's image collection, just scaled with the time beginning and the time end. Okay, so what we're doing here is data scaled. We're taking all these months and we're taking this data scaled and we're just adding images, median images, if there's more than 1 image per month. In this case, that won't be, so that's the actual image itself. And so once we've calculated our months, so we've basically created our time series, meaning our time series of our time series, we just then align it with an image for each of those months. And this is basically what's happening here. So this is our standard code for generating the dates. If you were to think about Excel now, to generate column A, which is your dates from January 1960, and then on the second column, you basically just add your data. In this case, we just add the images. And that's basically what we're doing in this piece of code. Okay, now remember these variable names, again, by month, any, end, these are all up to you. But remember, this is important because this is the link between the months and your images, your image collection, your scaled image collection. Okay, so remember this name here. This is very important. That name there must refer to the image collection, whether it's the image collection as is, data sets, or whether it's the image collection scaled. That's up to you. Okay, but remember, bring in your system start because you're going to need it here as well. Okay, so image start starts with the first date. So this is just in here. It starts with the first date, and you add median images to each of those consecutive months. In this case, we're not using median because there's only 1 image a month. But let's say it was yearly and there was a number of months, then you will use this reducer. And then basically we're just printing by month, meaning how many images there are. We add a color scheme. Oh, this is not really this is just to add the first. Okay, so why we're creating this is just we're adding the first layer of this image collection to our layers. But this is obviously not necessarily. You can actually just delete this. This is just to bring an image in. But for the purpose of what we're doing, generating this is not really necessarily. But it does. This is just the image here. You see there. This is the standard image. But as I said, for our purposes, actually, we can delete this. Okay, we can delete this. because all we're interested in generating. And then I'm printing this. I'm just going to plot this as a time series. And there's my code for print. What I'm going to print, I'm going to print the image in a series format. What I'm going to print this by month. Now, what is by month? By month is all of this. Okay, this variable by month is creating the monthly, the dates, and adding an image to each of those monthly dates. So that's what by month is. Okay, so that's the image collection. You'll see there. That's the image collector by month. You'll see there. Image 1, start date is 1960. Okay, January. Image 2. You'll see if I go there, start date is February 1960. See, that is what we've created. It's got an image, it's got a band, it's got one element, it's got DMMX. See, that's what we've generated here. So what I want to do is I want to export, I want to convert this whole thing, this image collection here that we've created, this by month image collection. I want to convert into a time series, and this is what I'm doing here. So my region of interest, and again, I'm putting a median reducer there, but that's standard practice. In this case, it's not going to work because it's just one image per month. I'm scaling it. Again, play around with your scale, and then I've just got a title here. Now you can add the Y title and X axis title, a Y axis title. That's totally up to you. But for me, I'm going to stick with this because all I'm interested is the data itself. I'm going to export it to Excel. Okay, I'm not interested really in presenting it in Google Earth. I'm interested in the underlying data and exporting it to Excel. Okay, so by using this code, starting from my dates, and then I'm plotting my time series. And there it sits. Okay, now you can change, as I said here, you can play around with novelties like the color of the time series itself, or the lines, type of charts, all those things you can play around. I'm not interested in that now, but you can play around if you want to. So once I've done this, as I said, now I can just go and click on this expansion button. It will open up here, and I simply just download it to a CSV. I click on download CSV, and it will save as a CSV file, and you just save it to wherever you want to save it. And from there, you can just convert it into Excel, and there you go, pops your uncle. Great. So that's just, but this is now, as I said, for my region of interest as a whole. So this is the average maximum temperatures for my average as a whole. Okay. So this is big. Okay. So this may or may not be relevant for any specific locations within my region of interest. We don't know. We already know that the coastal areas are much cooler than especially the northeastern side of my region of interest. So it's most probably somewhere that is most probably a temperature somewhere around here. Yeah. So as I said, that brings us to this 1,000 points. Okay. So I've got it for my region of interest, but I'm also interested for these individual points so that we can see by how much does temperatures changes, where it increased the most, where it increased the least, where it's the highest, where's the lowest, all these things that we can now do within our region of interest. That's additional to this particular one. Okay, so this is where my random points come in, and we've already been through my random points, setting up my random points file. And I said, I want a feature collection. So I want at the end of the day, before I start with the data, the time series itself, I need to make sure that my feature collection is first of all loaded as a feature collection. It's referenced as a feature collection, and it has this unique column, or this ID column that we're going to use. And remember that I've called it point. Okay, so that's important. I've referenced it as point. So that's important. Okay, so remember that. Okay, so now I'm going to start with what they call the triplets. Okay, so this is the code to generate the monthly, in this case, maximum temperatures per location for this period 1960 to 2022. So that's what I want to create here. So I first start with, I reduce my regions, and I'm going to, this is it, here I'm using this region. So I'm reducing it to this 1,000 points. Okay, so I'm using this, and I'm using the median, and I am interested in the maximum temperatures. Okay, now these are just basically normal code, so copy and paste it as is, leave all the names, etc., exactly the same. So I'm not going to go for this. Okay, so again, also this code here, row IDs, column IDs, it generates it automatically, and I'm saving it as a table, etc., etc. So here I'm just creating the table itself. Okay, so in this case, I'm generating the images, and here I'm generating the table, and now I'm going to add the data in the table. Now, this is where it becomes, sorry, this is where it becomes, you see, this is where we now merge the table and the data, and this is where that column becomes important. This is where the column becomes very, very important. You'll see there, point. Okay, if you don't have that column, it's not going to load. Okay, if you don't have that column, it's not going to generate the statistics. Okay, remember there's your image ID, which matches this image ID here. So remember your image ID here and your image ID there must be matched. Okay, because that's why you do these matches. It's matching now different variables or different unique identifiers. Okay, so point, it's identifying the locations, that unique identifiers, and the image, it's merging it with the actual month itself. Okay, and yeah, so and I said we're getting the maximum temperature data, and obviously once we've okay, so here we generate our images, here we're generating our table, and here we're matching the table with the images. Okay, so that's what we're doing here, and it's called time series results. And then basically I'm just exporting it. This variable I'm going to export, remember there it is, I'm going to export it, there's a description, to my project folder as a CSV. Okay, so once I've generated using this triplets code, okay, this is fairly standard, I said leave everything as is, except make sure that you change your collection and your label or your variable, your band, okay, or your variable. So that you need to change, and this you need to change for your specific purposes, whatever that. And remember, we're working with our image collection. There it sits there. Remember that's the image collection. So that's important to remember. Bring in your image collection there. Make sure that you've got the right band or variable that you're going to work with, and your image, your feature collection with that additional column. So that's important regarding this piece. This print is just basically printing this one here, which is just printing, you know, there's a point there. Remember, there's a point there that I'm looking at the TMX. And this is just basically creating the format of my table. This is just formatting the table. You see there, it's a table. It's going to have rows and columns, rows and columns. Okay, and then it matches the rows and columns with the monthly maximum temperatures in this case. And then I'm presenting it. I'm creating it by using that unique identifier. And then I print it. For interesting, that would be this variable, this that I've printed here. Okay, the time series, I'm printing it, but remember we're only printing one location, but there are 757 locations. And you'll see this one here has a, so we can, so that's January, February, etc., etc. So that's a time series, but only for 1 point, so we want 1,000 of them, and then we export it. Okay, so then we run our code. We run it. You'll see there in the taskbar, this West Coast max temperature, this here it sits there, is available for exporting. So I just basically click run. You'll see it's a CSV. It will go to my project. I click run. Okay, and then once it's done, it will be indicated in blue. Here, it's successfully done. It's got this tick here, etc. Now, you see that it took 5 minutes for this because it's 1,000 points. So it's quite big. So 1,000 points, that's in, what's it, 60 years, 750 months. So that's quite a large data set. Okay, so once I've done with this, I can just go to my project folder, my Google folder, and there it sits. And obviously from here, you can just go and you can download it to your project folder on your desktop or your laptop, and from there you can just work it. Let's have a look and see quickly. If I go into, you'll see it sits. There it sits. Okay, so if I open that, see, there's the folder of the CSV file itself. There's the CSV file. Okay, so now remember, I have to convert the CSV file into Excel file. So I just highlight my data. I go to data. I go to text to columns. I go to delimited. Go next. Remember, it's a comma CSV comma file. So I separate by comma. You'll see in the window it works, and I just press finish. Okay, and then it sits. So for each location, okay, so there's your system index. Don't worry about that. That's not important. But there's December 1960, February 1960. If I go to the right, you'll see there's my points file. Remember, this is the one that I've created in Earth Engine. There it sits. It will be unique. So that will be the unique identifier for each. Now I can convert this now into 1, 2, 3, 4, 5 if I want to, and there is the centroids for each of those points, and I can just convert that also just into an X and a Y column, like rather than having it as one item in a column. I can now just, again, using text to columns, I can create an X and two columns, a lat and a long column, so that we can bring them in as individual locations, let's say in QGIS or wherever the case might be. Okay, so there's a time series for this particular one. Let's see if I can, actually there's a lot. Okay, let's quickly see if I can convert, create a time series. It's now only 2000. Okay, so let's speed it up a bit. I need to go to 1960, so 1980s, 1970s, and 1960s. I should always be there. Now, I need to first convert this into commas. So I'll go to home, I'll go to find, I'll go to find what point. I want to replace it with a comma, replace all. You see 756. And then I'm just going to go insert line graph. You see there is that. Okay, so that's the time series of maximum temperatures for that specific location at centroid 18 and minus 32. So that location, the time series, and so forth and so on. But I think you get the idea that once we've generated in the time series itself in Earth Engine, we can now export it to Excel, and from Excel we can do all sorts of things with it. Okay, so that is in a nutshell what we've done in this tutorial, this video tutorial, in that we've created a map or a time series for our region of interest as a whole, and we've created a time series for each of these 1,000 random points. Main thing, remember to add that column and give it a name. Okay, well, we'll continue with it. Thanks for early morning video tutorial. I hope you enjoyed it. I hope it's still making sense and you're following. If you have any suggestions or comments, please feel free to share it with me. And thanks for joining me on this remote sensing journey. Stay tuned, lots more to come. And as I always say, sharing is caring. Please remember to like, subscribe, and to share the video. And until we meet again, see you on the other side.